This is combinations. Combinations are an extension of what we talked about with permutations. Permutations is the way that you can arrange the letters or the elements of a list. Let's talk about the three-letter permutations of D, E, F, G. Like 4 letters arranged into groups of 3. Permuted into groups of 3. So the formula for us from the previous lessons and the activity from this entire lesson was 4 factorial over 4 minus 3 factorial, which is 24. So there are 24 total ways to rearrange 4 things 3 ways uniquely. But let's talk what a combination is. A combination is going to say, I don't care about order. Combination, order does not matter. We just want to have the collection of those items. So let's start with question 1A. Start at the top left, DEF, and then we're going to look through the entire list and we're going to cross out all of the outcomes that contain the exact same letters as DEF, even though they're in a different order. So keep it, cross it, cross it, cross it, cross it, cross it out. Okay, I got rid of 5 of them because there are 6 total ways to rearrange 3 letters. We're keeping 1 of them and we're saying all of these other things are the same because it's about the collection, not about the order. So EDF is the same collection of those 3 letters as DEF, and we don't need a double count. So we're going to cross out. Okay, next up, we're going to find all the DEGs, and we're going to cross out everything else that uses the letter D, the letter E, the letter G in a group and say those don't count. Like this one, like this one, like this one, like this one. There's one more. Oh, here it is. Okay. Next, we're going to keep, I'm just staying in the left column. Why not? I could pick any spot over here, but, we're already looking over here on the list. So let's keep DFG. Keeping DFG, getting rid of anything else that uses those 3 letters because we're going to say they are a collection that is the same as. So that's gone. That's gone. Yep, that's it. Okay. And then last of all, since we're here, we might as well just keep EFG. Again, kind of working, top down, left to right. And EFG is found there, and found there, found there, and found there. Oh, that's all of them. So really, I'm only going to keep the collection of DEF, DEG, DFG, and EFG. I'm only keeping 4. There are 24 total different ways to rearrange 4 letters 3 ways, but we're only going to keep 4 of them because the other ones are some arrangement but using the same letters, and that's not what a combination is. A combination is just the collection of those things. So start at the top left, done. Move to the next outcome, done. There's nothing left to cross out. The arrangements that we did not cross out are called combinations of 3 letters from a collection of 4. A combination is an unordered, no order, unordered collection of items. You can use different notations for the combinations of R elements taken from a collection of N elements. They have this like hexagon diamond thing where N and R. We use the actual from the calculator, NCR or CNR. Or this notation, and you'll actually see it later on with parentheses where it's a number over another number. So those parentheses are a way for us to let us know we're talking about the structure of a combination. Let's consider the 3-letter permutation list of DEFG. And I think I need to find that page. Oh, of course. It's this one up here, right? It's this one. So this is the permutation list of DEFG. So considered. How many combinations of 3-letter strings are there? Literally, it's all that I highlighted. Combination, 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 combination. And they're different from each other. Otherwise, I would have crossed them out. There are 4. I just counted. That's how I got there. I just counted. I crossed out things that matched, but I'm just counting. Now the notation for C3, for choose 3, represents, oh, that's a good one. Choose. So for choose 3. From 4 things, let's choose 3 of them. How many different choices do we have access to? The notation for C3 represents the number of combinations of 3-letter strings formed from the 4 letters D, E, F, G. Write a value in factorial notation to make the equation true. What we know from up above is there are 24 permutations. And to get down to 4, we have to divide by a number. We have to divide the 24 by a number to get to 4. 24 divided by what number is 4? 24 divided by 1? No. 24 divided by 2? No. 24 divided by 3 is 8. 24 divided by 4 is 6. That might be the way to think about it. 24 divided by 4, what number? 24 divided by 5? 5 point, was that 2? 5.4, okay. 24 divided by 6. 24 divided by 6 is 4. Okay. From this list, 6 is 3 factorial. So the whole point of permutations as a formula is to find a way to re-express the permutation in factorial notation. Combinations want that same result as well. Combinations want to be expressed in factorials. So if you remember the formula for permutation, it was n factorial over n minus r factorial. And then now what we have here is 4 choose 3. So we have 4 factorial over 4 minus 3 factorial. And then we're going to divide by 3 factorial. This is a complex fraction. I don't like it. There's too many fractions going on. Let's try to compress it. This is technically over 1, so we're going to flip and multiply, which means flip and multiply. So then we have 4 factorial over 4 minus 3 factorial times 3 factorial. Oh, does that really work? Let's check with a calculator. So where'd the factorial button go? Is this here? No. Is it in one of these other, is it here? Oh, it's here. Okay, so I'm going to escape out of this, and I can just go fraction 4 factorial on the bottom, parentheses. I know 4 minus 3 is 1, but I want to show you that the formula does maintain that consistency. 4 factorial times 3 factorial. Enter. Yes, we get a 4. Confirmed. Okay, one more thing before we go. Oh my gosh, excitement. Calculator work. We love it when calculator work works the way it's supposed to. Combination, NCR, just like this. There it is, menu 5-3. 4, choose 3. Love it. Okay, thanks for watching. Let's do some more practice with combinations. See you in the next episode.